In this screencast, we will be looking at two separate topics. The first one is surface water, water on the surface of the earth that is fresh water and can be used for things like industry, agriculture, and drinking water. The second topic will be altering the availability of water. So first, let's look at surface water. There are several types of surface water. The first one is rivers, and that's fast-flowing, moving water, and floodplains, which are areas alongside the banks of rivers, which periodically are flooded by rivers. The second category is freshwater wetlands. Freshwater wetlands are areas that are submerged in water, at least partially or completely at various periods during the year. Freshwater wetlands are important to all living things because they can help to absorb storms and other types of damage. The one that we will be mostly focusing on here, though, are lakes. Lakes are bodies of water that are primarily standing bodies of water as opposed to rivers which are faster flowing. Continuing on now with surface water. Surface water is primarily made of lakes, which are larger bodies of standing water, and ponds, which are smaller bodies of standing water. And both lakes and ponds can be classified based on their level of primary productivity. Remember, productivity means the amount of photosynthesis and so forth that is going on in a particular habitat. So the three types of primary productivity produce either oligotrophic lakes, mesotrophic lakes, or eutrophic lakes. And this is a natural way for these lakes to exist. Oligotrophic lakes have low productivity because they have low levels of nutrients, such as phosphorus and nitrogen, that feed organisms like bacteria and algae. So an oligotrophic lake would be, a nice, clean, crystal blue, clear lake. A mesotrophic is a moderate level of productivity. And the last one is a eutrophic lake. A eutrophic lake means that there are high levels of productivity. It means that there's naturally a lot of nitrogen or phosphorus in the water, and therefore there's lots of algae or bacteria in that water. So you get that murky, no longer crystal blue type of lake. And these are all three naturally existing conditions. Later, we'll look at something called cultural eutrophication, which is where a lake, which was either oligotrophic or mesotrophic, becomes eutrophic because we add nutrients such as nitrogen and phosphorus to the water. So that's it for surface water. Now we're going to turn attention to how humans alter the availability of water. There are 4 ways that humans alter the availability of water, and 3 are shown on this slide. The first one is using an aqueduct. An aqueduct is a canal or a ditch that carries water from one location to another. So it might look something like this. Remember, one of the earlier case studies was about Mono Lake in California, which was thought to be a useless lake because there were no fish in it. So they removed a great deal of the water from this lake and others and put it through long canals like this one called aqueducts in order to bring it to parts of California that didn't have enough water for its growing population. So these can be in the ground or even above ground. A second way that humans alter the availability of water is desalination. Desalination is a process which removes salt from a lake or ocean salt water to obtain fresh water, drinkable water, usable water for irrigation. And this process is not very efficient at this point in time. So desalination is only used in a few areas. There's continues to be research into it, but right now desalination does not play a big role in altering the availability of fresh water. You can remember the term desalination because S-A-L-I-N is like the word saline, which is salt. That, for example, the salt water or the saline that you use for contact lenses. A third way of altering the availability of water is through something called fish ladders. So when you have a very steep incline, either as a result of a dam or just difficult terrain, people can build fish ladders, which have steps so that the fish that are trying to migrate, so the migrating fish can move up one step ladder at a time. So let's say the fish was in here, it could gather some energy, move to the next tier, rest there, then have the energy to move to the next tier. And this actually exists on the Cape. They have herring runs that have small dams, and so they've put up these fish ladders to help the herring to migrate. Last but certainly not least, on the ways that we alter the availability of water are levees, dikes, dams, and reservoirs. So let's look at these. These are barriers that are built the first two are barriers that are built to prevent flooding. Levees are enlarged banks that are built up on either side of a river to prevent flooding. You may have heard the term levee with regard to New Orleans and Hurricane Katrina, when the water surge was too much to prevent the flooding and exceeded the level of the levees. They weren't built high enough. So this is a nice-to-know term, but not a must-know term. Dikes are very much like levees, only they prevent ocean waters from flooding adjacent land. So what we really want to focus on here is dams. So a dam is a barrier runs across a river or stream to control water flow. So for example, you have a big river here, and you have a dam across the river, and the flow of the river is in this direction. So when you do that, there are a number of benefits and another number of consequences. So the first thing that happens when the dam is first erected is that there is a buildup of water behind the dam. And that water is called a reservoir. It's stored there on purpose. But when that water is collecting behind the dam at first, it floods the adjacent banks on either side. And that can provide a problem because in some places there are people who live there that may have to be displaced. That happened in China with a giant dam that was recently built, the largest in the world. And it's in China, and it displaced millions of people who lived along the banks of those rivers. A second problem with flooding that land behind there is that sometimes it has a lot of vegetation, and when you put water over top of it and flood it, that vegetation starts to decompose anaerobically without oxygen, and then you get the stink, you get the methane from the decomposing material, and so that's not good to release extra methane into the atmosphere. There's some benefits, though, to dams. You can control water flow. So if there's too much water flowing up here, you can build up your reservoir and prevent it from flooding on places that are downriver from the dam. So that can prevent flooding, which is very useful. You can also produce hydroelectricity from dams. We've seen before how certain forms of motion, be it wind or hot water creating steam, in this case the flow of water, can be used to turn a turbine which generates electricity. And the generation of electricity in this case is with limited environmental consequences, though there are still some, and it's inexpensive. So that is another plus of having a dam. As you'll see, though, there are some other considerations. So I'd like you to consider this map of the Colorado River. So the Colorado River is a mighty river starting here in the Colorado area, of course, near Boulder. And you can see it's very wide here, and it flows down and down and down. And there are a number of smaller rivers and other tributaries off of the Colorado River. And as the water in this river moved down, there are a number of dams that have been erected. So here's one dam right here. And then we have a Glen Canyon Dam, which is a large one. Hoover Dam, built many years ago. And look, another dam, and another dam, and another dam. And then the water empties into the Gulf of California. So if you have water being blocked here and a reservoir being built behind it so that they have water for drinking water for people or whatever other use, and you have another dam here which also has its reservoir, and one here, one here, and one here. As you can imagine, by the time you get down to the Gulf of Mexico, how much water do you think makes it down to that Gulf of California? Not nearly the flow that would have happened if there weren't any obstructions along the way. So see if you can figure out why that might pose a problem for those who are downriver from one or more dams. It would change the amount of water that used to be available to those people or to those habitats. It would reduce the amount of water flowing through the various tributaries. And those tributaries may provide water for various other locations throughout these basins. So that can be an issue. So now let's look at the balance of benefits and consequences of putting up a dam along a river such as the Colorado River. So one of the potential benefits is the creation of hydroelectric power, which is cost less and produces less air pollution. You also have the benefit of flood control for downriver areas. And you have water storage for municipalities. So if you know you seem to be heading into a low precipitation, you can stop letting that water flow and maintain the water in the reservoir so that you have enough. As I mentioned, there are some environmental consequences to damming. One is habitat destruction and species extinction. That has happened in the flooded areas that are where the reservoir is then formed. Behind the dam, you get a great deal of sedimentation of soil particles. There are toxins that can be released from flooded soils. There can be an increase in diseases, particularly bacterial diseases. And, and the decomposing biomass releases methane. And then another consequence of damming is that downstream there's reduced flow and there are reduced nutrients and sediments as well. But there are potential benefits in the future if conservation can be employed and if we can manage climate change that will make this less detrimental. Last, we'll look at some real-life consequences of putting up dams and consequences for the people downriver. And we'll look first at the case of Georgia and Tennessee. 200 years ago, when they were trying to build the border, it was supposed to be along the 35th parallel to separate Tennessee to the north and Georgia to the south. But they missed by 1 mile. They were 1 mile off when they set up the border. So though the border is here, if it was along the 35th parallel as was intended, the border would be here where it says proposed border in the dotted line. So you can see the present border misses entirely this access to the Tennessee River on this part of Georgia and keeps all of that access to water in Tennessee. The proposed border, or the border where it should have been along the 35th parallel, would give Georgia access to a large amount of water from the Tennessee River. So this has caused them to propose, to move the border to where it should have been. So Georgia tried suing Tennessee to get a piece of that lake that's fed by the Tennessee River, but they did not succeed, and the battle is still sometimes ongoing, sometimes not. They have tried passing various resolutions to get it, but it won't work. There are also areas throughout the world where this happens. I see I'm out of time again for this screencast. So up next, we will have how humans use and sometimes overuse water for agriculture, industry, and household use.